start. So I will do share the screen. Okay, today we will do the email as well as DNS, domain name service. So this is at the application layer. So DNS actually we have already deal with a little bit in IP layer. So we say that, okay, how do I know the IP address for the other guys? So at those times, so we say when you figure out the DHCP server will give you not only the IP address, but also give you the gateway. And then of course, you will give you the DNS server address. It probably will be handled at your gateway. So this is DNS domain name service. And another one is very, you should be very familiar with is the email. So electronic mail. So at email, we were talking about the protocols behind the email, SMTP, Simple Mail Transfer Protocol, POP3, and IMAP. Okay, well, wait a moment. So email, for the email, so we have the three major components. So we have one, actually it's two parts. One is the user agent, one is the mail server. And fundamental protocol between mail servers, we call it SMTP, so the Simple Mail Transfer Protocol. So the user agent, actually, you should be very familiar. This one is like an Outlook or your iPhone mail client as well, or you have HTTP mail. So you open the web browser and open the mail. So this one is the user agent. User agent usually do the things like our human being, right? We just write the mail editor and send out, or I receive the mail to read the mail. So this one is the user agent. And usually you will do is the user agent may not save the mail, so they may store the message at the server. So for the mail server, so usually mail server has two parts. The green part you can see on the top of it. So on the top of it is the mail queue. So the green one is the mail queue. This mail queue is to say the mail server may not, most of the time the mail server will connect many user agents. So this one, when they send out the email, they will go to the mail message queue. So it's queued, and based on the first come, first serve, then your mail will go to the destination. So this is the mail, the green part. The green part is sending out. So it's likely at our at your building. If you have a large building, there has one mailbox is outgoing mailbox. So this one will go out. So at the post office, you will see there is a box, right? You can put your mail into their mailbox, so they will send it out. Okay, the yellow one. The yellow one is kind of the mailbox for each users. So this each user, they will keep your received message. So usually the mail server will keep a lot of this yellow block. One yellow block is for one user, so represent one user. So you may have a lot of these yellow blocks, and each block belongs to one user. So it's associated your username and the password. So your email address probably is your email address plus your password. So it will give you this message belongs to you. So the other message belongs to the other users. So this one is the mailbox. It's stored in the yellow one. So then we need to set up the function similar like the mail deliver. So like our post office, right? So this post office protocol we call the simple mail transfer protocol. So this one is based on client and server architecture. So when I send out the mail, I'm the client. When the received mail, so the other guys, if I want to send email from here to here, then this guy, the mail server, will become the client. This is the client. And this one will be the server. So for our socket programming, this server will be always on, right? So your server socket wait for the client to say hello to me. And then the client is the active, it create the connection, TCP connection. So why is TCP? Because we know that we need a very reliable data transfer. Or this email, you don't want to lose any character. So this one we through the TCP. But the delay doesn't matter. That's why you will be queued at the mail server. So then if I see this is from you, this mail is from you and want to send to this server, then I will set up the connection to this guy and then transfer your data. Okay, so this one is the picture of the email. So now the email systems. So usually we use 25 to be a port for the email transfer. And we have directly transfer from the sending server to the receiving server. Sending server is the client and the receiving server is the server socket. So this one run the client socket, this one run the server socket. Okay, so then we have 3 phases of transfer. So the first one, we need to handshake, right? For the TCP connection, we know that the first thing we need to do is a 3-way handshake. So the high level at our application layer, we also need to say something, say hello, I want to transfer some data. So this one is handshaking, grading. Not only at the TCP layer, but also at the application layer. And then I can start transfer the data. So this one means I transfer the mail message. And then when I finish, I close the socket. So the client socket will be closed. The server socket still wait for the other connection. Okay, and so we have like HTTP and FTP, we have some commands and response interaction. So message should be encoded as ASIC code. So this one is quite straightforward. Okay, let us see an example how we send a message from Alice. So Alice to Bob, okay, B. Okay, so Alice say create one message. So and provide the destination email address is bob at some school, for example, hpu.edu. So then the first thing is Alice side will send to the mail server. So you create the message, then the second one you send a message to the mail server. So the message mail server will queue it at its queuing, at its queue. So it's at the green portion. So it's 3. So it's stored at the queuing place. And then when your Alice mail move to the front of the queue, means the next sending out email is Alice email. Then the mail server will look, okay, someschool.edu, right? This is your destination. Bob is the name, right? So this guy is my mail. So this one is some school, for example, hpu.edu. Okay, so I will connect to the mail server. So make sure this one is not 3W, okay? I don't put 3W there. So this is not the web server. So this is the mail server. So the mail server, hpu.edu mail server. So mail.hpu.edu. So this one is the mail server. I will contact this mail server to say, hey, I have one email to to you for the customer for you of you. So this one is to say, okay, great. This one the server socket will accept if it's okay. Then it will set up the connection. So this is a client server connect to the server socket. Then this 4 will send out the message, and this message will be kept at a certain place. Where do I put it? I based on the name say Bob, right? So this is the mail server. So this portion is no need useful, no need to consider. So this one is already goes to the set mail server. So what I need to worry about is, okay, who is the receiver, actual receiver? So actual receiver, say this is Bob's email, so mailbox. So this is Bob. Then I will keep Alice email to here, to the Bob's mailbox. So after a while, then Bob log in using his mail, using his agent, like the Outlook or like others, so Google Mail. So then it will connect to the mail server, and then mail server will say, hey, there's a new message to you. Okay, and then Bob can retrieve this email and read the message. Okay, this is the whole process to the system. Okay, so far so good for this high level email, high level discussion of the email. Okay, so now let us see actually what is the message. Okay, suppose I want to send the message to the hamburger.edu, hamburger.edu, crepes.fr. So this is the sender. So this is the sending server. Yeah, this is a little bit of headache for S and C. So S is the receiver. So the receiver. So this is the receiver server, and the C is the sender. Okay, so make sure. So the server will say, okay, the first, at this moment, you don't need to worry about the number at the beginning from the server. So the server will provide the status. So this is the status we will discuss. Like the HTTP, you will have 400, 200, like this number. So for us, same for the email system, I have the server status information. So at this moment, you don't need to worry about this status. Later, we will discuss. Do I have? Maybe not. So, but it's okay. So 220 means it's available. The active mail server. So say mail server is now working. So this one is. And what is the mail server name? So the hamburger.edu is the mail server. And the sender, so the sender will say hello to the server to say, hey, this is mail. This is the mail server. Crepes.fr, so it's the sender server. And then the receiver server will say, okay, hello, hello, and then pleased to meet you. So this one is a kind of polite thing, interaction. So this one is a handshaking, okay, handshaking. So this one is a handshaking and a greeting, right? This is like a greeting, okay, greeting each other. to say, okay, how are you, right? Okay, this one is the greeting one. Then the client will say, okay, I have a mail from Alice. So, okay, Alice, you can send, sender is okay. And receive, so this is the sender. From to is the receiver. So the Bob Hamburg at hamburger.edu. So this one, the server will, the receiver will say the recipient is okay. So this guy is definitely have the mailbox at it. So 250 means okay. So everything is okay. And then if this one is, and this one, this guy is means that my connection is okay. So this one is for the specific sender and the sender. For the specific sender and the receiver. Oh, specific sender and the receiver. So specific sender is Alice and the specific receiver is Bob. And this guy, these two are both okay. Then sender okay, receiver is okay, then that's okay. Then the sender server can start sending data. Okay, this is the data. And then end with dot on the line by itself. So this one is, do you like capture? How about the pickles, whatever? So the data, all those things. And when you finish, you put a small period here. So that, okay. So just one dot is okay. So then message accepted for delivery. And then the client will, the sender server will quit. Finally, the server state will send a message to, this one is, this one, this guy is the data transfer. So the data is, this portion is data going on. And the last one, when it's finished, then this is a quit portion. Quit portion is a client server. So the sender say quit, then the receiver will, the receiver actually is the server socket will tell that, okay, this guy closing the connection. I close the connection. Okay, so 221 is means close and 220 means open, right? So 220 is open, 221 is close, 250 means everything is okay, and 354 is the end. Okay, give the information to say how to end this email. So far so good for the interaction. Okay, so let us move forward. So this one you should be very familiar is the your mail format. So you have the header and you have the body. So header is actually you should include to from subject, right? So this is similar to when you open your Outlook or you create a new message, you will always see this headline. To is the receiver, from is the sender, subject is the kind of thing, what kind of topic you want to talk, and then this one is the SMTP mail from receive to commands. So then the body is actually your writing, right? So you write your email. So then this one is the, okay, between the server. Also, SMTP used for the sender. So between the sender and the server, so the sender Alice to the server, you can treat like the same thing. You send the message to the server, right? And the server to server is also send a message to server. So they can share the same thing. So they can share the same protocol, just push the data from the one place to the other. Okay, so now when we do the receiver side, can we use SMTP? The answer is no, because I don't know whether Bob will when Bob will access the mail server, right? When you write the email, definitely you know that when I click send, it will communicate with the server to deliver, right? When server connect to server, it definitely know that they will transfer the data. This server is available, then you can transmit the data. But for the client, so the receiver, Bob will not always online, right? It's may not 24 hours a day, so 7 days online, so every minute online. So this one is not reasonable. So the Bob need a special protocol, which is to retrieve from the server when it connect to the mail, connect to their his user agent. So this one we have two, actually three. One is HTTP, right? You have already used it quite often. You just go to the web page and use HTTP to connect to the mail server instead of the web server. So you communicate with the mail server and retrieve the data. So this time, I don't need to consider too much about that, but this time I will do is two things. One is POP, Post Office Protocol, and IMAP is Internet Mail Access Protocol. I will do more details on the first one, POP3. Actually, it's called POP3. So Post Office Protocol version 3, so POP3. And then IMAP will provide more features than POP3. But the fundamental things is the same. So for POP3, actually we have two phases. One is called authorization. Authorization is usually give the username and the password. So you connect to the server, you provide the username and the password, and the server say, okay, I check this too, it's okay. Then you can pop, actually you pull the information from the server. So this is the list, how many emails is still there. So for the transaction, it will be, okay, this is the number one, how many bytes, number two, how many bytes. And then the client will say, okay, retrieve the first message, then it give you the first message and use the dot as the end. Okay, the server will end this using the dot for each email. Then delete one means you will delete the first message at the server side. Okay, so the server will delete it. So POP3. Okay, so protocol say that you will delete the first message and then you retrieve the second message and then you get the message and then you delete the message. So this one is not message one. So this one should be message two contents. And then to quit. So it's okay. So this one is POP3. Usually when you create at your Outlook, you use POP3. Then by default, it will delete the mail at the server. So next time when you go to other computer want to access this mail, sorry, you cannot access them anymore because it's already it's already deleted at the server side. So it's only at your original computer where you download. So this is the POP3 protocol by default. So let us talking about POP3. So based on this example, so the POP3 download and delete mode. So this is the download and delete mode. The receiver cannot reread the email if he changes the client. So you go to the other client, you cannot use it and you cannot check anymore. So POP3 also offers some options called download and keep. So it will keep it at the server side, but it's just make a copy and deliver the message to different clients. So the thing is for POP3 is stateless cross sessions. So if you close, if you quit here, next time you should always do this version, so authorization version. So your name and the password is not stored. Okay, for IMAP is everything will be stored at the server, IMAP. So it's not to use the download and delete version. So allow user to organize message in folders. So if you create many folders, so say this is the university mail, this is from faculty 1, this is from faculty 2. So this one is kind of my professor 1, professor 2. So you can create different folders. So POP3, you cannot do that. It's just download the mail. So like our post office, right? They just deliver the message, deliver the mail to you. They will not keep a copy at the post office. So it's download and delete. And then it will not organize your mail, right? It will be not say that this is for advertisement, this one is the useful message or whatever. So, or that one is your credit card bill. So actually, your post office will not do that. That's why it's our POP3 is, we call it the post office protocol. So it's like the post office. But sometimes we want to organize our messages and put into different folders. Then IMAP allow you to do that. And also IMAP will not do download and delete version. So every message is installed at one place at the server. So you go to any place, you can access that mail. Also, IMAP is a state protocol. So like like the HTTP with the cookies. So this one is also implement state. So it will, for example, it will keep your folders and mappings so that it will, next time when you get the new message, it will directly deliver to the certain folder, right? So this one is the IMAP. So any question? Okay, if you have no question, then I will move forward to the last portion of application layer stuff. So I skipped the peer-to-peer applications. If you are interested, you can look at my slides post on the Blackboard. So, but this one is the last thing I need to introduce. Previous three, like web, FTP, email, you can touch that one quite often, but this application, DNS, domain name service, this one is hidden behind your work, behind our network, but we use it every day when you access the network. So this one is quite useful, and I would like to introduce. And you can see that you cannot eliminate this service. Okay, domain name system. So the domain name system, DNS systems. So like people, we have many identifiers. So you have SSN, you have name, you have passport number, you have driver license. So this one is I can identify you through the other message. So for us, so we have IP address is for each destination, but we can also have a name, right, associated. For example, 3w.yahoo.com or 3w.hpu.edu. This means that I point to the HPU web server. Then the question is how to map between IP address and the name. If I give you the IP address, can you tell me the name? Or if I give you the name, can you give me the IP address? Most of the time, you may you may remember the name but forget the IP address most time. How many of you know? How many of you know the IP address of hpu.edu? So probably I don't know. If you know that, you can tell me. But I know I can remember the name, right? It's so organized and give us a very meaningful idea. So this one hpu.edu, right? So this one I can remember easily. So the domain name system, usually it should be distributed database. Next few slides we may compare why we need distributed database instead of concentrated database. Okay, then this one is application layer protocol. Okay, that's why we don't introduce at the IP layer, transport layer, not in the transport layer, not in the network layer. We introduce at application layer. So this one is DNS service, is a host name to the IP address translation. And the host also maybe is a host alien. So this one is, you may, for example, 3w.google.com. Actually, this one is easy for us to understand, to remember. But actually, this server is not the real actual server. This one is represent a group of server with a very, very difficult name. So this one is the very ugly, may not be ugly, but it's a kind of ridiculous name. So this one, but I give you the whole name. So how do we see the example? Let us see. So let us see. I stop share this one, but I will share. Okay, so let me share. This guy. So I will trace route to 3w.google.com. Okay, so the google.com give me this address, right? But its name actually is this guy. Okay, everyone can see. So everyone can see. So this one is actually the name for that server. Okay, Lex 17s14-in-f4.1e100.net. Anyone can remember? Okay, no one can remember, right? But this one is the actually still the 3w.google.com. So this name is easy for us to understand, but it represents a group of web servers, a group of web servers. So this time, this web server will, with this IP address, will be the server. So what is the real name? So this is the real name for that server. Then I should bind this name with the 3w.google.com. That's why you will see that the DNS should also solve this kind of questions. If I give you is this name, I should also give you map to this name, then this name map to this IP address. Okay, so different server name may have different IP, should have a different IP address, but this one is the global picture. So this one represent a group of servers. Okay, so far so good. Okay, so let us come back. Oh, the question is why not? Okay, so this one is means I give you IP address, you give me the results, right? So the other things you should also provide for the DNS service, you should also provide the mail server. So we have the mail server. So this one is also should be provided by the DNS. And for the DNS server, we should make it load distribution. Means we will have multiple DNS server, so that I don't want to keep everything into one DNS server. Why? Because the first one, DNS, is so important because no one can remember all IP address even. So we should have a DNS server to help us to translate from host name to IP address. If we centralize, then this one fell down. You totally cannot access the network unless you know the IP address. So then the second one is if you centralize the DNS, then you have a very large traffic. Think about millions of computers try to find the destination, goes to the one place to look at the IP address, then this one is quite not doable. And then the third one is also if it's centralized, then you will wait a very long time. And also it may be far away to the destination, and the maintenance is very, very huge. Think about how many IP address we have. So this one is it's not affordable. So it should be distributed. Oh, the distributed is based on the tree architecture. So we have the root DNS servers. Root DNS server is actually is just one thing is dot. Okay, dot is the root. Okay, then you have the com DNS servers for the company, org for the organization, edu for the education institution. So this one is the first layer. So the first layer server. So this one is the root server. This is the tier one. So then you can even under it, you can have more small DNS server like yahoo.com or amazon.com DNS server or microsoft.com DNS server. Or you have the edu, for example, we have hpu.edu DNS server. So this one is the server. So you can have further server. The root server actually is not just one root server. Here we have 13, I think, 13. Yeah, 13 root server. And I think most of them are in the US, So I think Europe have 2 and Japan have 1. So okay, so this is the sites. So this is the whole thing for the root server. The root server is actually the dot. So if you type in the, for example, 3w.hpu.edu, okay. So actually by default, you have dot after the final, the first layer edu, right? First tier. So this one dot is the ending. So this one is the root. Okay. So okay, so we have the TLD, so and the authoritative server. So this one is top level domain. So TLD servers responsible for, this is top layer. So .com, .organization, .net, .education, and we have certain kind of country domains like UK, France, Canada, Japan. So network solution maintains servers for .com, TLD, education, you will have .edu TLD, so it will be maintained at that one. Then authoritative DNS server is the organization's own DNS server, provides the host name, authoritative host name to IP mapping for organizations named hosts. So for example, under edu, we can create hpu.edu as the authoritative DNS. Then it will serve like 3w.hpu.edu. This one is for the web server. And we can also do the server for the mail server, right? So this one is a kind of authoritative under the top level. So top level is this guy. So it's this guy. Under it is the authoritative DNS server. And then we can also have the local DNS name server. So it's the local DNS server may not follow this architecture, exactly tree architecture. So inside, for example, inside the Yahoo, then we can have several local DNS to serve different, for example, serve different place, and they may communicate each other, and they may also connect to the yahoo.com DNS server. So this one is not a strictly tree architecture after the authoritative DNS server. Okay, then we call it local DNS. So local DNS, actually, we can see an example. How do we get the email, how do I get the IP address? So for example, I have the poly.edu, CIS at poly.edu, want to access the umas.edu, csumas.edu. So want to access one computer at umas.edu. So we have two ways to do that. One is called the iterated query. So this request, the host will call the local DNS server. So the local DNS server say, okay, I don't have any idea about this destination. Then I will call the root DNS server to say, hey, can you give me certain kind of information? And the root DNS server will say, okay, please call the TLD, top level DNS server. So this one is probably the edu. So the edu server, right? The edu server. So the edu server will say, hey, goes to the authoritative DNS server, which is the dns.cs.umers.edu. Okay, then it will send a request to this authoritative DNS server. Then let's go back. And then the last portion is, okay, the local DNS server will tell the requesting host, okay, what is the IP address for the destination? Well, you will see that actually this guy will be very busy, right? The local DNS server will be very busy because they keep asking different servers and get the information. Another way is called recursive query. So instead of let this local DNS server too busy, then it will do is, okay, I will send a request, send a request until the guy can answer what is the IP. And then it will go back through this recursive calling, trace back, so give the IP address. Okay, put the burden of the names resolution on contacted name server. So this one is not that busy because it just send and receive, right? This one is going on, then it's a kind of things. Okay, any question? Okay. Oh, so now, is there any issue? Okay, there's a kind of issue associated with this query. Is if I have another customers want to access to the same place, so it will do the same thing. Okay, it will follow the same style and say go back to the root and the TLD, then authoritative DNS, and then come back. But it goes through the same, right? So the issue is, okay, this guy query, this guy query later for the same address, same place, then it will follow the same rule, same way second time, but this is not a good style. What if I can store the information for a while so that later probably it will be reused, right? So then this one will be stored, and the next time when another user want to get the same place, it will directly, the local DNS server can serve it and give the IP address. So this one is a kind of issue we say, and how to fix it. So the fix it is the caching and updating the record. So once name server learns mapping, it caches mapping. Okay, it will cache this mapping, and then when the entry may be out of date, so it will delete it and start the query again. If it's a request again, so it will start this query again if it's out of date. Okay, so how do we maintain the DNS records? So the DNS record is store the resource records. So there's the record has four portion. One is the name. What is the host name? What is the value for this host name? The value is may not be IP address. So later we will look at why it's not always IP address, because you will deal with certain kind of bundle. So like 3w.google.com, right? It's a bundle. So this one is we need to deal with. Also, this one is this time I don't know. If you ask the server, which the DNS server does not know what is the solution, then it will give you the feedback of who should you ask, right? Okay, and then this is type. I will show different type, and the TTL is kind of the time. So it's a kind of time. So after a certain amount of time, it will be out of date. So this one is you will update later. So when the TTL goes to 0. Okay, so the question is different type will have different value. So I use type and the value to discuss. Okay, the easiest thing is the type equal to A. This means the value is the IP address. Name is the host name. Okay, so this one is the value and the type. Okay, so type A is quite easy, straightforward. Name with value is the IP address. Okay, so the next one. So if you give me the name, so I give you is a domain, is the domain name like the 4.com or yahoo.com, then the value of that one is the host name of authoritative name server for this domain. So why because if I give you this guy, say 3umass.edu, so because I look at the csumass.edu, then it will give you is the authoritative DNS server name. So dns.cs.umass.edu. So this is the domain. So I give you the domain. It will return is which DNS server in this domain. DNS, for example, dns.for.com is its DNS server. So it will be returned in its value. Then you can query the particular IP, particular host name within this domain. Okay, this is the second type. So I give you the domain name. You give me the DNS server within that domain. Okay, this is second type. The third type is CNAME. CNAME is I give you the name, for example, 3w.google.com, right? So this one is the name. Then the value is kind of the real name for that server. So just like the C in our, so just like this. If I give you 3w.google.com, it will DNS, it will give me this one as the feedback. So Lex17S14, this kind of ugly name. Then I will query this name and get this IP address, okay? So this, if I send this guy, then I will get the information is the type A information back. Okay, so okay, so this is the third one. The last one is the mail. So for the mail is the value will be the name of the mail server associated with name. So this is the value will be its mail server name. Okay, so this is the total 4 types of DNS records. And then the DNS protocol say that, okay, how do I get the IP address? This one is a query and a reply. So this is the header. So you have, you ask the question, then the DNS give you the server, give you the answer. So variable number of hours, right? So this one is a query and a reply style. Okay. How do I know this is the query or this is the reply? I use the flag. We have the flag here. So the flag will tell me that, okay, whether this is the query or this is the reply, or the recursion decide, or this one is not, use the iteration or use the recursion. And whether a recursion available or not, and the reply is authoritative or not authoritative. So it's the local DNS, or this one is the authoritative DNS. And then you can have many, many questions. So you have, okay, who is this guy? I give you the name. So I may require not just one, I can require many. And then the response will be the RR, right? So we discussed the type. There's four things is name, value, type, and the TTL, right? And this is the records for the authoritative servers and another helpful information. So let us see that it's example. Insert will be the name. This one is the domain. So it will give you is, it will insert two things into the DNS server. So one is what is the domain name and what is the authoritative DNS server. And this one is definitely NS, right? This is the domain. This is the authoritative DNS server. And then I give you the DNS server name and I give you the IP address. Definitely you have the type A. Of course, here I'm missing here is the TTL, right? So this TTL, you can, because it's at the TLD, so the TTL is very long. Okay, so this is the fundamental stuff for the DNS, but a little bit talking about the DNS problem. Because DNS is so important to the network, so this is also the one of the important part for us to protect. Because if some guys attack the DNS, then it can get a lot of information. This is one thing, because the IP address and the name, right? They can get a lot of information. And another thing is, they can affect, so the DNS server, if the DNS server is down, means it cannot serve, then it will affect so many people, because you cannot access the network if DNS server is down. Okay, so we have the denial of service. So this one, denial of service, is sometimes if the root server now is well protected, so it's not successful to date. But the previous is yes. So they have the traffic filtering and the local DNS servers, cache IPs, all these things. But if it's dangerous, if you some guys attack the TLD, so top level DNS servers. So this one is the denial of service. This is one kind of attack. And another attack is I try to get the information. This one is try to deny the service so that it will affect the people to access the network, to get the access certain web page or mail server. So this one is the purpose. So it's stop your working. And another one is try to get the information. We have one thing to get the information is man in the middle, so I can catch the queries and instead of you, and then I get the information from the feedback from the DNS server. This one is I get information. Another thing is I give you the wrong information, redirect you to some web page, so that similar to the previous web page you have already seen. So and this time you will see this similar web page probably will ask your username and password or even more information like credit card or whatever. So then the bad guy can get all this information. That's why, because I poisoning the DNS so that it guide the web browser to load the web page from the other place, not the real original one. Then I can get all the information of the customer. So this one is also very bad. So that's the security issue associated with DNS. So if you are interested in the DNS computer security, so this one is a kind of network security. So this one is one of the major research work done on this one. So that's all for the whole thing, I think. Is it? Yeah, this is the last slides. So I have one thing is the summary, so you can look at it. I will not repeat it. Any question? Okay, if there's no question, then I will